YouTube or whatever. Okay, now, a couple of people away. Alright, first one. Thank you. Guys, focus. Now, can you mark yourselves, and then I'll pick these up at the end of the lesson. Alright, so you've got n times n, which is the which is row times column. So, how many rows? You've got 3 times 1, sorry. Not 2. 3 times 1. Alright. 3 columns, 3 rows, 1 column. Boys, calm down. Alright, you're making me stress. The next one, B, you've got 3 rows and 2 columns, so 3 by 2. Right, give yourselves a tick if that is it. Moving on. Calculate 2A. So 2A means this. 2A means you've got 2 lots of everything inside this matrix here. So everything inside this matrix, that's A, right? That's where this A came from. That's this thing, right? And so 2 of everything inside is going to be 2 times 1 is 2. 2 times negative 2 is negative 4. 2 times 4 is 8. Right? Give yourself a tick. Okay. The next one, a half B. So a half B is a half with everything inside as above. Alright, so you got 1, 0, negative 2, 2, 1, and 3. Alright? Now, this means, boys, come on. Right. Now, if you want to do this in the calculator, that's fine too, but this is quite straightforward that you probably don't need to do it in the calculator. And everything inside multiplied by half gives you, and I'm going to run out of space, so I'm going to write this down in decimals. That's going to be half, like half times 1 is half, so 0.5. 0 times half is 0. That one's negative 1, 1.5 here again, and 1.5. Alright? Or 3 over 2. Okay? So 1.5, same as 3 over 2, that's okay, doesn't matter. Okay? Alright, give yourselves a tick if that's what you got. Now, sorry for the formatting, this P is meant to be in line with the Q, but just somehow it came out weird. Now, P plus Q, to add them together, you must have the same order. Let me make that very clear. This is a 2, sorry, not 2. This is a 3 by 2 matrix, and this is a 3 by 2 matrix. You can only add them together if they have the same order. So in this case, yes, you can add them. So what we're going to do is we're going to say that P plus Q is actually 2, alright, 2 and, I'll write it all out just for completeness sake, alright, plus 1, 2, 1, 0, 4, 3, okay. Now we add each of the same elements together in turn. So this one will be 3, 5, 2, 1, 4, 5. Okay, so we're adding each of these together in turn. Now, this is where you might want to use the calculator. So what I'll do is I'll show you the calculator, and this is where you might want to start using the calculator because you've got 3 over 2 later at the end. So we go to the calculator. I might just delete all so we can show how to enter in the matrix. Alright, I'll enter this matrix in. This is a 2 by 2 matrix. Okay. Now I'm going to enter in the, oh wait, sorry, it's not a 2 by 2. It's a 3 by 2. Okay. So we've got 2. We've got 2, 3, 1, 1, 0, 2. So I'm just going to call that matrix A. Matrix B is another 3 by 2. Alright. 1, 2, 1, 0, 4, 3. Okay. Now, this next one I'll speed it up. We'll go down. Now, Q take P has to be, in this place, B. So I've got mat B. I've got shift. Matrix B minus matrix A. And this answer should be -1, -1, blah, 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 blah. So this is going to be, so using the graphics calculator, that's the G. Alright, and that gives you -1, -1, 0, -1, 4, 1, and end that bracket there. Alright. Now the 3 over 2 P minus Q. Let's have a look. Now P is matrix A. So I'll go 3/2, which is 1.5, or I can do the fraction button. So let's do the fraction button. So I go 3/2 matrix. In this case, P is matrix A, right? Minus matrix B, which is our Q, equals, and that's what we get. Right. So again, the graphics calculator. And let me just pull that out so I can actually copy this down. So that's going to be 2.5, 0.5, 1.5, -4, 0. Okay. Alright, moving on. Now, yeah. You can go toilet. Boys, are you marking yourselves here? Fine. Yeah, hey. Yeah, he is. Alright, so question 3. The ice cream stall sells both green tea and black sesame ice cream. As you see, these are my two favourite colours, Asian flavours. And if I have pandan, I'll have that too. Now, a small portion, this is unrealistic, right? Let's get the number small. $1, very cheap. $1.50 for large for both flavours, right? So same price for both flavours. The amount of ice cream sold during the day is shown below. There's the ice cream table. Now it says here, write down a column matrix. Key hint, guys, column matrix. So that means the cost of the small and large portions. So we want the cost of the small and large portions. So the column matrix C is going to be something that looks like this. 1 and 1.5. Done. Alright? So then that's your small, that's your large, and then this is the dollar. This is the price at the top. Right, so if I label the matrix, the column is the dollar cost, the rows are the sizes. Alright, given that matrix N is 3, 4, 6, 3 in rows, they're going down, state the order of the matrix and describe what the numbers actually mean. So this is a 2 by 2 matrix. Alright, so that guy is a 2 by 2 matrix. Now what do the numbers mean? Anyone get a hand up? What do the numbers mean? What does it tell us? Number of ice cream sold? Yeah, for each flavour? Yes. And for each size. Alright, good. Remember guys, not just the number of ice cream sold, but the number of ice cream sold for each flavour and size. Context here. This question is giving you context. You've got the sizes and you've got the flavours. Right? So I'm going to say number of ice cream sold per flavour and size. Right? Just trying to write really fast here because I know I'm conscious on time. 20 minutes. Now state why the matrix multiplication Cn cannot be completed. So matrix Cn. Why can't it be completed? Well, demonstrate that it can't be by doing it like this. C is a 2 by 1 matrix. N is a 2 by 2 matrix. Now these two numbers in the middle are not the same. So they are of incompatible order. Right? So it cannot be done. Not the same. Alright? So incompatible order. If you tried it on the calculator will say no. Right? You say order error or something like that. Okay? So not the same. Not identical. Not identical. Evaluate NC. So if CN cannot be done, what is NC? Now, in this case, it says show all working out. If you use the calculator and you didn't show the working out, like you could use the calculator to check your answer, right? If you didn't show the working out, this is where it differentiates between, a B grade or a C grade at this point. So if you've got everything right up to now, you're looking probably at a C, right? Or C star, right? If you're able to do this on the calculator, I'd definitely be like, say, C+, yep, you know how to do matrix multiplication. If you show the working out, then that's a B. Right? B grade for this section of the test. So let's actually show, I guess, the working out NC. So what was N again? Let me just have a look at my question here. I've actually written this down before. Right? So N is this fella. So NC is equal to 3, 4. So this is the number of ice cream sold for each flavour and for each size. And then we're going to multiply this with the cost of the ice cream for small and large. Right? And this is going to yield us. And this is the working out what I'm talking about here, which is we're going to multiply. I'll do this in a different colour, right? The first element of the first row with the first element of the first column. The second element of the first row with the second element of the first column. Right? So again, it's row to column. Remember. So row, first with first, second with second. Now, I really want to emphasize this. Right? The 3 is that first thing on that row. The 1 is the first thing in that column. First to first. The second, right, second here. Second one in that row, and the second one in that column. Right? Second, and then you repeat again. Now what this will yield, if you write the working out, you got the 2 by 2, and then you got the 2 by 1, that means this will become a 2 by 1 matrix. So this will be another column matrix. Right? That's what you'll get here from this answer. You get a 2 and a 1. Alright? And let me finish writing this down. So we'll have 3 times 1. So we'll have 3 times 1 plus 4 times 1.5. And then I'll have a 6. Again, now second row. So this one here, bottom row, second row. 6 times 1 plus 3 times 1.5. Okay? And that's going to give us, if you do the sums, like, you know, what's 4 plus, 4 times 1.5. What's that? What's 4 times 1? That's 4. And then what's half of 4? 2. 2 plus 4 is 6. So then that's 3 plus 6 in total. So 3 times 1 is 3. So you're going to get 9 at the top. And then the bottom, if you do all the sums here, if you do it with the calculator, that's fine. Like I said, check the calculator, no problems. Right? So if you put in the calculator a matrix N and a matrix C, bang it together like this, you get this answer, you spit out. Right? Again, that's a 2 by 1 matrix. So this is a 2 by 1 matrix. Right? That's the answer. Now, what do the numbers actually mean? So this matrix here, this matrix here, the 9 and the 10.5. Well, let's decipher this. What do we have in the on N? Like, what does N represent? Let's have a look again. N. Green tea, black sesame. So the rows for N are the flavors of ice cream, yeah? So in here, I'll label this, green tea, black sesame. So G for green and black sesame for B. And then for the 3 and the 4, that's small column, large column. Right? So this is small and this is large. Now, when you multiply this across, right, what you're going to get is, think about what happens here. I'll point it out on the board. You've got the green tea flavour, the small, multiplied by the price of the small. Right, that's the price of small. Small, number, the 3 sold, multiplied by the $1 for each small. The 4 that you sold for large, multiplied by the price for the large price, for the large prices. So 4 lots of large at $1.50 each, 3 lots of small at $1 each. Add it together. So what flavour of ice cream does this represent? Green tea or black? Green. Green tea. So remember, first column, first row across. Right? That's green tea and that's black tea. So you're going to be able to work out the working out to tell what's what. So this is actually the total revenue for each flavour of ice cream. Right? $9 for green tea and $10.50 for black you spell sesame? Sesame. Alright, done. Total revenue, or the total price, total amount of dollars. Alright, total revenue. So, total revenue, dollar sign. Right. So these are actually dollar signs. Total revenue. There's your green and there's your black sesame. Alright. So it's combining the small and the large flavors together to find the total cost. Okay. First page. This page here. That one there. It's alright, this is recorded. I'm going to put it up on, I'm going to put a link to YouTube. And I'm going to put this on Daymap. So if you want to hear the explanation. Alright. Anyhow guys, I really got to move to the last one, otherwise we're running out of time. We'll do the recording. Alright. Now, the cost of hiring a car. So this one here is going to sort out the students of who's going to be the A level here, because this question is unfamiliar because there are two ways of doing this question, right? Two different ways of getting the same answer. Okay. The reason why this is harder is because it doesn't say to you write a column matrix or write a row matrix. Right? You can build the matrix either way. So, guys, we've got company A charges $66 per day. Company B charges, only 48 cents per kilometre. Meaning company B doesn't actually charge any money for a daily hire. They only charge for kilometres. Company A just charges per day. Doesn't care what kilometres you do. Right? And company C is like both. Like charges both daily and per kilometre use. So, there is also some information saying that this person called Kim, this market, needs to hire a car for 4 days. And he will drive about 560 kilometres to and from the town of Kumaduk. Right? Yeah, Kumaduk. Right. Now, using the information above, write down two matrices. One representing the information on cost, and the other matrix for the car hire needs. So let's go over the cost matrix. Alright. So the cost matrix could look something like this. 66 and 0, 0 and 48 cents here, $30 and 25 cents. Alright. That's what you could do. So what I'm doing here is that this is the day, this is the kilometre price, this is company A, company B, company C. Alright, can you do that? Tick. Alright, the other way you can do, or you could do this. I might need more space. Or, you can write it the other way around, which is you can write here 66, 0 and 30. This is company A, B, C, and you can have day, right all down there, and you can have kilometres here. So you have 66 and 0, 48 cents, and what was it, 25 cents for this one. Right. So you can either have a 3 by 2 matrix or a 2 by 3 matrix. Either is correct in this situation, because it doesn't say like what order of the matrix you're writing in. Both are still correct. However, to do the last bit, part B, you have to choose a combination where your multiplication actually can work out. Right? Now for the other matrix, K, I'm going to call it K. This is Kim's higher needs, so that one's going to be K here. Alright? That one's going to be K. Now, he needs 4 days and 560 kilometres. So K could be 4 days and 560. Right? That means that this is day, and then this is KM. Or, you can write K as a row matrix instead of column matrix. You can write day and 560 here. So you can have this as day, and this is kilometres. So either set of answers, I'll give it to you. Okay? Now, the second part, using matrix methods to find out how much each company would charge Kim based on his hiring needs and states which company, Liam, hey, can you move over there? I just don't want to keep talking over you. Right, we only got 10 minutes left. Go, move your stuff over there. So, check your order of the matrices because you've got either a 3x2 and a 2x3, or in this case a 2x1 and a 1x2. Now, which combination of multiplication could I do here? Could I do, say, for example, could I do these two together? No. Because that's a 3x2 and that's a 1x2, so I can't do C times K, because that's 2 and a 1. That doesn't work. Can I do the other way around? Can I do like K times C? No. 2 times 3? No, that doesn't work. But I could do probably this pair. Yeah. Right? Because that's a 3x2 and 2x1, so I could do CK. Yeah. Can I do KC? No, you can't because that's 2x1. 1 and 3 aren't the same. What about this pair here? Can I do, if I use this pair, can I do CK? No, I can't do CK, can I? That's 3 and 1. But can I do KC? Yes. Yeah. So some people would say KC, some people would say CK. Right. So I'll show you one of these. You want to do the first one? Yeah. Okay. Oh wait, where are you all gone? Oh, I thought you wanted to see the answer. Fine, don't see the answer then. Okay, so I'll do the first one. So if we take the first one, let's take this one, and we're going to move it there. Okay. Yes, okay. So I'm going to do CK because I'm going to have a 3x2. So that's going to be 66, 0. Well, that's going to be too small, so I'll write it out later. So that there. And a 30 and a 0.25. There you go. And that's a 3x2. And K is a 2x1, I believe I did. So that's going to be 4 days and I think 560 kilometers here. So 2x1. So we check we can do the multiplication. All good. These numbers are the same. Alright. Now, at this point, I would encourage you to use the calculator. Alright. If you don't use the calculator, it could look a little bit, I should put messy. So, can I bump this down? You know what, let's bump it down to a new page. Alright, we'll go down here. So, alright, put the arrow down there. Alright, so bump it out to a new page, and actually I'll finish off the bracket later. So what do we get? We get the row and column. So we've got 66 times 4, so you've got 66 times 4, plus 0 times 560. 0, alright? So, and look, I'm only going to write this one once, right? Because that goes to 0, okay? And the next one I won't bother writing it. So I'll just put 0 here. So 0 times 4 is 0. And then plus the 48 cents, what's the dots? 48 times 560. The next one is going to be 30, right? Times 4 plus the 25 cents times 560 Ks, and finish the matrix there. And again, this answer is the 3x1 matrix. Right? Just so you can see, that's a 3x1 matrix. And if you tally up all the numbers, right, you should get, I think, 264 for company A, company B, $268.80, and the last one is 260 for company C. In other words, which company is cheapest? So state the cheapest one. Yep. So you can say Kim should hire with company C at $260. All right. I get that in the full screen? Yeah, there we go. Alright. And I'll finish the recording there.